So in this video, we will be continuing our discussion on HashTable implementations, and I'll be implementing three different HashTable functionalities in Python. Specifically, I'll be adding the add functionality, which allows you to add a key into a hash table, such as hashtable.add. And then we can say a value such as May 12th. And after we input May 12th, we're going to be able to successfully add the corresponding value for the key, which is 5 for May 12th, into the correct indice. We'll also be able to get where we can do hashtable.get, and then we can specify which key we want to get the value for. And if we get May 12th and we've already added May 12th into our hash table, this will output 5. Finally, we're going to do hashtable.delete, and we can specify the key whose value we want to delete. Okay, so now that we're here, we can copy and paste the function key, or the hash function that we implemented in the first video, and let's just make sure it works. So our goal is to add 3 functionalities within a class, 3 methods. .add, which will add the corresponding key, .get, which will return the value associated with the corresponding key, and .delete, which will delete the value associated with the corresponding key. So all of these have a key that we pass into the method. So in order to begin, we have to create a hash table that has 11 indices, and we picked 11 because that was how many indices we decided would be most appropriate for the number of dates and the number of values we had. So array will be our variable that we put our hash table into, and we'll say none for I in range 11. So this means that none will be the value of every index in the range of 11, and there will be 11 different spaces. So if we print array, we see that none is associated with all 11 spaces. And if we print array 0, we get none. If we print array 10, we get none. If we print array 11, we should get an error because it's out of range. So we know that we're only messing with the first 10 indices. So now that we have this, we can begin our class implementation. And this implementation will have all of our methods that we're about to create. So first we need to have an init function definition that will do exactly what we implemented here, which was initialize a hash table. And we want this to be very flexible because we want to be able to change this range depending on the size of the array. So we will create an opsize variable and set it equal to 11, and we will call opsize in here. So whenever we want to change the size of the hash table, depending on what hash table size we want, we can always just change this number. And let's also copy and paste our hash function. And now we can begin our implementation. We get an error, which is this indentation. And if we want to call hash function now, we have to call the class that it's under, and then hash function. And then we can say May 12th, and we should get something, 6. Cool. So now that we have this working, we can begin creating our add definition. So def add self key value, and we want to create a variable that is equal to this number, because May 12th has index 6, so whatever value we associate with May 12th will go into index 6. So 6 will be our location variable, and we'll set that equal to hash function key. And we should actually call it self, because we are accessing a function that is in the same class as this. So now that we have that, we can use that number, which is going to be, in our case, 6. So index 6 will have the corresponding value that we input into this function definition. Let's see if it works. So HashTable dot add May 12th 5. We get an error, add missing one required positional argument value. So this is happening because we need a self in this hash function, and we also need parentheses. And now we have a different error, op size not defined, and it's probably because we have to call this self.opsize. So that should fix it. And we're still getting an error for add. Self dot hash function, self dot array. I feel like I'm missing something very obvious. This should also be self.opsize because it's whatever this number is. That shouldn't be the problem though. Location equals self.hash function key self.array location equals value. That is weird. Oh, duh. We have to have parentheses. And HashTable object has no attribute array. Dot array. Self.array, because this should be self.array. Okay, we fixed a lot of errors there. And also, let's simplify this. So instead of having HashTable, we can set a variable equal to HashTable. So we can only use we can just use t. So t equals HashTable, which means we can always reference t now. Cool. So now let's see if we have this. We actually added this value by printing the array. Print array. And it didn't work. Let's do t.array, my bad. There we go. So t.array is the array instance of our class HashTable. So t.array will show us that yes, we have 5, which is the corresponding value for the key May 12th. And now we can continue to let's just add one more just for safe measures. May 13th, and its corresponding value was 4.8, I believe. So t.array will now show us 4.8 in index 10. Cool. So now let's develop the get functionality, which will output the corresponding value associated with the key that we pass in. So self and key. Key is going to be the only user input that we have. And let's do the same thing we did with add, where we create a variable that is equal to the output of hash function. So if it's May 12th, the value will be 8, 6, 8, yeah, 8. And then for I in range self.opsize, if I is equal to location, then we return self.array I. So this is basically saying that we go through the array, and if the index is equal to location, we return the value associated with that index. So that makes sense because if we run everything and we do t.get May 13th, we should get 4.8 because 4.8 is the associated value. And now that I'm looking at this, we can actually simplify get even further, in that we don't even need the for loop because it's not even necessary because we can just say location, right? Because location is equal to the index where our key's value will go into. So if location is equal to the index, then we just return the value associated with the index. So that should also output the same value. Yep, 4.8. Cool, so we made it simpler, and we can also see if we output the value for matrix, and we do. 5. Cool. And lastly, we can create the get or the delete method, which is self key, and same thing, we create the variable for self.hash function key. So for May 12th, location will be equal to 8, and then self.array, the location, so index 8, where the key of May 12th is, and from add we see that the value is 5. 5 should now be none because we're deleting it from that location. So we'll set the location, which is index 8, to none. 0, 1, 2, 3, 4, 5, 6, 7, 8. Cool, just making sure. So now that we have that done, we can test it out with t.delete. We pass in the key, and we don't expect any output, but if we do t.array, we see that we've actually changed the 5 to a none. And that's the basic functionality. We've successfully been able to develop a class that can add, get, and delete key value pairs. And it's super important to recognize the errors that I debugged in the beginning, which were with self, because self is necessary for every time we call a variable that we instantiated within the class. And I believe the error was self.opsize, so instead of opsize it should be self. Array should be self.array, and hash function is another function within class that needs to have the self. So these are just very small things to be wary of. Awesome. Hope you guys found this video helpful. I'm going to be doing a HashTable interview problem, and I'll also link that in the description once I'm able to upload that. But hope you guys enjoyed it, and let me know how your data structure journey is going, and let me know if you have any questions. Peace.